Hello everyone, today we are going to discuss this question called string reorder from cses problem set. Okay, so the question says that you will be given a string. The length is n and it consists of characters capital A to capital Z. So our task is to reorder the characters of the string so that no two adjacent characters are same, right? So like if I have AA BC, so I have to report this kind of a string where no two adjacent characters are same, right? And the other condition is it has to be lexicographically minimal. I hope you understand what you mean by lexicographically minimal. That is, let's say if we are able to report two kinds of strings, one is this, or uh, let's say this, okay, and the other string that we can report is maybe this, right? But this is lexicographically minimal as it starts with A, so it compares the first position, so A, and this is B, so A is smaller, right? That like by ASCII value we are comparing, right? So therefore this is lexicographically minimal, right? Okay, so now we will see the approach. Okay, let's take a few examples. Let's say if I have A B C and I tell you to print such a string, can you do that? So if we try, so let's put A first, then we have to put either B or C, then let's again put A, then again we need to put either B or C, so let's put C, then let's again put A. Now you can see there's one location left and we have to put A here, or we can put A here, but that doesn't help as it gets repeated. So what we can see is that the length of the string here is somewhat n. Okay, so it is 6 here. So if the occurrences of the most frequent character, right, if the occurrences of the most frequent character is greater than n by 2, right, then nothing can be done, right? But should we do n by 2? Let's check for some odd string. So like if there's a string of length 7, we can manage 4 a's, right? So 7 by 2 uh, would be 3, so I think we should use n plus 1 by 2, right? We should use n plus 1 by 2, that for a string if the length is n, right? So the most frequent character can occur n plus 1 by 2 times, right? But if it is greater than this, then you have to report minus 1, right? Like for let's say for a 6 character string, we can maximum accommodate 3 most frequent characters, not more than that, because then there would be repetition, right? So we can't do this. Okay, uh, so probably you've understood that what we like the algorithm basically is, if we have a b c, so what we will try is we'll start with the most frequent character, right? And we will also have a check that uh, whatever is the frequency left, right? So in the rest of the string, like in the rest of the string, now the length is 4, right? And there are 2 a's left, and we can accommodate 2 a's in a length 4 string, right? So that's what we need to look, that can we go ahead with this. So let's put a, and then we won't put a, so we would take a variable called last char, right? And would store the last char, which is a here, right? So and then when we will iterate, so we will get that a is equal to the last char. So then we can't put a, we have to put something like b, right? Okay, and then we will again put a, because our target is to finish up with the maximum number of a's as possible, right? And then we can put c, and then we'll put a. So that is the idea here. Okay, so the main condition to check here is that whichever character we put, right, whichever character we're putting, uh, at that time whatever is the most frequent character, for that we'll use a variable called mode and we'll store the most frequent character, right? So whichever is the most frequent character, that has enough space. So when will that have enough space? So like after putting a, we'll calculate the length of the string that is left, right? And let's take that in a variable called total. So we'll take that in a variable called total, and we'll check that whether this most frequent character, which is like, we'll check whether the frequency of this most frequent character is less than equal to total plus 1 by 2, right? So this has to be one condition, and another condition also we can use, that is frequency of the current, that, let's say now we have put a, so putting a should not happen in a way that it later creates a problem, right? So we can also check that frequency of current is less than equal to total upon 2, right? So those are the two conditions. So let's now look at the implementation. So I'll tell you. So in the int main, what you will do is you'll first take input of the string, and then what you will do is, so here we are taking the input, so then what you will do is you will actually iterate throughout the string, right? So you will start like this, that for int I equal to 0, I less than, so you will take n as s dot size, right? And then you will do I less than n, I plus plus, okay, and then you will take a variable called filled, you will take a boolean variable called filled, and you will mark it as false, right? So till the time it is not filled, right, till that time you will continue a loop from c equal to 0 to c equal to 20, c less than 26 actually, to c less than 26, and then c plus plus. And before this you will take a map, right? Whenever you're taking input of the string, okay, you will take a map, and you will store the frequency of elements. So you will take a frequency map, and you will do frequency of c plus plus, so you will store the frequency of elements, right? Okay, so then now we will iterate through each character, and we will check that, okay, so before this we also need to take a last char variable. So let's take your last char equal to -1. We will set our last char as -1, and then we will start this loop, like the c equal to 0, this one, and we will decrement uh, the frequency of c, and then we will check that whether we can put it there. So what are the conditions? The condition is that it cannot be equal to last char, so your c cannot be equal to last char, right? What is the other condition? That it is still not filled, it is still not filled, right? And your c equal to 0, c less than 26, this already applies, right? So then we will check that whether we can put c, because putting c might not work always, right? Because then we will use a different function, and we will check whether putting c is possible or not. So how are we doing that? I have already explained the two conditions. So what you will do in that possible function, now I will explain the possible function. So in the possible function, what you will do, you will take a, like, you're basically doing possible of c, so that is coming as c only here, right? And then you will basically calculate the mode after each step, right? So you will go through this loop, int c equal to 0, c less than 26, c plus plus, and then you will start here, and you will check that you will basically, what you will do is, you will have a mode. So at the beginning, let's set mode equal to 0, and then we will check that if frequency of c, like whichever character we are taking, right, if that is greater than equal to the frequency of the now set mode, like whichever is set as mode now, if the frequency of c is greater than mode, so we will just update our mode to c, right? So we'll just update our mode. So I think that is quite easily done. And then once this updation is done, and this we are doing at every step, right? And once this updation is done, then we will check that final thing, that we will basically return if the frequency of our mode, whichever that is, if that is less than equal to total plus 1 by 2, because that needs to happen for sure. And along with that, we need to check that our frequency of our current variable, that is c, that is less than total by 2, less than equal to total by 2. Now see, if you don't check this condition, then also only this condition would work, right? Because this doesn't happen, like these are quite like they have some intersection, right? Like we say now that a intersection b exists here, so basically using this condition is already sufficient. uh, Using this is kind of a subset of this only, right? This is not a very separate condition, but I saw a few people using this condition, and using this does not do any harm, so you can also use this. But this condition alone takes care of the fact that this is also satisfied. because this mode thing and the c thing, both are interlinked. Like if it goes less, if it goes greater than total by 2, then already the mode is going to be affected, so you don't need to think about that, right? So uh, I believe you understood, so thank you.